Hi guys, this is Saurav here and welcome to the reaction mechanism series on the Vedantu channel. We are conducting a number of such sessions so that your understanding of organic chemistry is as good as mine or anybody else. And in this session, we would be discussing Pinacol Pinacolone Rearrangement. This is the fourth video in the series. Until now, we have covered Wagner-Mervin rearrangement and allylic rearrangement. We are in a sequence of covering up all the rearrangements in which carbocation is involved. So the next video would also be on the carbocation rearrangement. Why we are taking carbocation rearrangement? Because a lot of such reactions where carbocation is involved as an intermediate are very vital for any entrance examination as well as for 11th as well as for 12th. So JEE Mains advanced aims, you can talk of NEET, Olympiads, class 11th examination, class 12th examination, all of these examinations किसी न किसी point पे carbocation rearrangement का question आ जाता है, okay? And इसको समझना बहुत मुश्किल नहीं है. Pinacol Pinacolone Rearrangement is the exact takeaway from whatever we have learnt earlier, that a carbocation, if is unstable, will undergo rearrangement, and whatever product will be formed will be an outcome of this mechanism. Okay, so let's not waste any time and start with today's session, which is on Pinacol Pinacolone Rearrangement. हमेशा याद रखिए कि from this specific topic, Pinacol Pinacolone Rearrangement, JEE has been giving questions on a regular basis, as well as this topic is very vital for the NEET or AIMS examination. इस topic से questions आने ही आने हैं. Almost every year एक question या फिर every 2 years में एक question इस topic से आ जाता है. Okay, so let's start with today's session and let's learn what this rearrangement is all about. So Pinacol Pinacolone Rearrangement is an acid catalyzed rearrangement reaction of vicinal diol. A vicinal diol is an alcohol with two OH groups in which the OH groups are on adjacent positions. आप देख लीजिए इसको. So we have two OH groups on adjacent positions. This represents a vicinal diol. The first compound, Pinacol, is the trade name or the common name for a compound which is 2,3-dimethyl butane 2,3-diol. So this is known as Pinacol. Now for the sake of convenience, we call every vicinal diol as a Pinacol. ये sake of convenience के लिए हम बोलते हैं. Means अगर हमारे पास कोई भी ऐसा vicinal diol compound आया, we'll call it a Pinacol. So this Pinacol, if is made to react with H+, then a product like this will be formed, which will be known as a pinacolone. So the acid catalyzed rearrangement of vicinal diols through carbocation intermediate to aldehydes or ketones with elimination of water. So three things are important. One is the substrate should be a vicinal diol. Second, it should be an acid catalyzed reaction. And third, it should be generating a carbocation intermediate through which a product would be formed. Product can be one of the two carbonyl compounds, which can be aldehyde or ketone. Okay, so let's look at the mechanism of this reaction. बहुत simple mechanism है. इसको हमने बहुत सारे तरीके से पहले भी cover किया है. Let's look at how this mechanism will proceed. So let's say we take this compound and we want to write the mechanism for this reaction. So there is a OH group and there is a H+ ion. What will happen when you see a OH group and a H+ ion? Invariably the OH group will take up the H+ ion. सबसे पहले तो ये होना है. Okay, now what will happen? So we write CH3 OH CH3 OH2. Oxygen will get a positive charge. Now the moment oxygen gets a positive charge, what we should do is remove H2O molecule, which will get removed, and I'll get something like this: CH3 OH the positive charge. Always perform that rearrangement. Now, how do we know that this carbocation will rearrange or not? Now, looking at this carbocation, it seems like ये तो एक 3 degree carbocation है, इसका rearrangement होना नहीं चाहिए. So, this carbocation is 3 degree. Let me write it over here. This carbocation is 3 degree carbocation or tertiary carbocation. Tertiary carbocations are fairly stable. Now, why would a tertiary carbocation rearrange? So, let's look at what would be happening to this compound. So, if I write this carbocation and rearrange this, हम कैसे rearrange कर सकते हैं? I bring a methyl group over here and I would obtain CH3 positive OH CH3 CH3 CH3. ठीक है? तो now this carbocation is formed. Why is this carbocation more stable than that? This carbocation can be qualified as a 2 degree carbocation. बोल सकते हैं ये 2 कार्बन के साथ अटैच्ड है, लेकिन ये 2 डिग्री कार्बोकेटन इस 3 डिग्री से ज्यादा स्टेबल क्यों है? क्योंकि यहां पे what is happening? Resonance is taking place. Resonance is occurring at this point. I'm writing methyl groups as Me. So what we can see over here is oxygen is getting a positive charge, and this entity, this carbocation is more stable than that one which was originally formed, because of the reason that the carbocation is getting resonance stabilized. So resonance stabilization is imparting more stability to a carbocation where there is only hyperconjugation. यहाँ पे सिर्फ hyperconjugation है, यहाँ पे resonance नहीं है, लेकिन यहाँ पे resonance हो सकता है. Lone pair single bond positive charge conjugation present है. So after this is formed, what would happen is, हमने क्या सीखा था पहले, that if there is a acid catalyzed reaction, then you add H plus in the start of the reaction to catalyze it, and to make it work as a catalyst, you have to remove H plus at the end of the reaction. तो आप H plus को remove करते हैं. आप H plus कैसे remove करोगे? This will go out, and what would happen is this CH3 C double bond O C Ne Me. You'll get this product. Okay? This is the mechanism. Okay? Now remember, in any mechanism there is something known as a rate determining step. Rate determining is the slowest step of reaction. Now, आपके पास 2 intermediate बन रहे हैं. One is this, one is this. You're getting 2 intermediates. So always remember, rate determining step of this reaction is the formation of the very first carbocation. सबसे पहला carbocation कौन सा बना था? ये वाला. This is the very first carbocation which is formed. This carbocation will be the formation step of this carbocation will decide the outcome of the reaction. The formation step of this carbocation will decide the outcome. So this is the RDS. This is the rate determining step of the reaction. ये conversion जो है, that is the rate determining step of the reaction, not this one. ठीक है? Let's learn it in a different manner. Let's look at the application of this. So, इसको समझने के लिए कि rate determining step ये ऐसा है क्यों, let's try to solve this question. So we have a vicinal diol, and both of these are being made to react with H plus ion. Now what will be the outcome of the reaction? Now, एक बात बताइए, if I form a carbocation at this position or at this position, will there be any difference? Will there be any difference if I form a carbocation at either of these 2 positions? No, because the groups are alike. So what I do is I form a carbocation at any of these two positions. So if it reacts with H plus, let's say this OH reacts with H plus, and I remove a molecule of water, I will get PH, C, Me, OH, C, Me, pH with a positive charge. Okay. Similarly, let's try to work it out over here. Okay. Now, if this H plus is being made to react at one of these two positions, we can get two different types of carbocation. I can get a carbocation where this carbon has a positive charge, or I can get a carbocation where this carbon has a positive charge. Okay. So I can get something like this, or I can get something like this. Fine, I can get something like this. Now I have to identify what would happen at this in this carbocation. Question is, will the pinacol formed in both the cases be alike? Experimentally, it has been found out that the pinacol formed in both these cases are alike, exactly alike. हम कैसे identify करते हैं? और ये exactly alike होने के कारण हमारे पास inference कैसा आता है? So there is a phenyl group and a methyl group over here. Between phenyl and methyl, what will migrate will be decided by the migratory aptitude. ये हमने पहले भी सीखा है कि what would migrate will depend on the migratory aptitude. So remember that the migratory aptitude is H, pH, Me. Okay. H, pH, Me. Hydride will migrate faster than phenyl, which will migrate faster than Me. Or Me3C will migrate faster than Me2C, which will migrate faster than MECH. तो मतलब एक 3 degree alkyl unit will migrate faster as compared to a 2 degree alkyl unit. Okay, so let's look at this trend, pH, Me. So between pH and Me, what should migrate? pH should migrate. So pH comes over here. What will I obtain? C, OH, positive Me, C, pH, pH, Me. Now I have to remove a proton and form a ketone. ठीक है, आपने करना क्या है? You remove a H plus ion and form a double bond, carbon oxygen double bond. You remove a proton and the compound that you would obtain is this Me, pH, pH. Okay, so in this case, the product obtained is this one. Now, since I have already established that the product obtained in both the cases are alike, now what we have to do is identify which of these two carbocations will react. Now, पहले मैंने आपको ये बता दिया कि rate determining step कौन सा होता है. Rate determining step is the step in which the first carbocation is formed in pinacol pinacolone rearrangement. देखिए हर reaction का rate determining step different होता है. Okay, every reaction is a different rate determining step. In this reaction, in all pinacol pinacolone rearrangement reactions, the formation of the very first carbocation will be the rate determining step. So between these two carbocations, which is more stable? This one is more stable because this is benzylic, this is non-benzylic, this is 3 degree. So this will be more stable. So I will not take this into consideration. Now once this is formed, which one of these two groups will migrate? There are two methyl groups, there is no competition, so one of the methyl will migrate and the carbon oxygen double bond can be formed. So आपको करना क्या है? You form the more stable carbocation, migrate a group, depending on the migratory aptitude and form a C double bond O. So यहां पे हम C double bond O बना देंगे, कार्बन, मिथाइल, phenyl. So what we obtain is the same product. You can see MEC double bond O, C, MEPH, MEC double bond O, C, PH, ME. Exactly the same compound. Okay. So writing the product is pretty easy. You remove a OH group, migrate a suitable group, and from the carbon from where you have migrated a group, you change it into a C double bond O. Let's look at some few other questions. So, how do we solve this question? This question is very simple, yet a number of times this question has been asked in a number of competitive examinations. So what we have to do is we have to form the more stable carbocation first, and then we'll move in the next direction. So between these two carbon atoms, which one would be more capable of acquiring a positive charge? I am writing both the carbocations. अब बताइए कि कौन सा carbocation बनेगा? I'm writing this. Or PH, OH. Which carbocation will be formed? This is benzylic, and that is a positive charge formed on a ring. Positive charge formed on a ring is not favorable if the ring is less than 6-membered. So if it is a 4-membered ring or 5-membered ring or 3-membered ring, you cannot form a positive charge on the ring. Okay, on an atom of the ring, you cannot form a positive charge because that will be unstable. It causes a lot of strain, and in the GOC series, this must have been taught to you that comes under bare strain theory. Okay, so smaller than 6-membered would not want to acquire a positive charge. So this is not formed. This is formed. Okay, now what will happen? We have this. I had taught you in Wagner-Mervin rearrangement that there is a certain method of rearrangement where the ring expands. So in this case, ring expansion will take place. हम कहां पे बोलेंगे ring expansion होगा? इसका एक बहुत सिंपल सा तरीका है याद रखने का. If there is a 4-membered ring and a carbon attached to 4-membered ring has a positive charge. If there is a 5-membered ring and a carbon attached to 5-membered ring has a positive charge. Okay, in both these cases ring expansion will take place. Okay, 3-membered ring with a positive charge attached to it will not expand because it's a highly stable carbocation. So this will expand, and expansion के बाद you will get something like this. PH, C, PH, what have I done? It's very simple to understand. So this is, let's say 1, 2, 3, 4, 5, 6. मैंने क्या किया कि मैंने 2 and 6 के बीच का बॉन्ड ब्रेक कर दिया, and I have formed a bond between 1, 6. I have formed a bond between 1 and 6. Now I get a 6-membered ring with the positive charge on the carbon atom, which is labeled as carbon number 2. Which is labeled as carbon number 2. So what would this structure look like? ये आपका 6-membered ring हो गया. इसमें से किसी एक कार्बन को कार्बन नंबर 2 बोल दीजिए. ओके, सो ये हो गया कार्बन नंबर 1. दिस विल बी 3, 4, 5, 6. आर्बिट्रली किसी को भी 2 बोल दो. ओके, जहां पे 2 आपने लिखा है वहां पे एक OH ग्रुप आपने अटैच किया था. You will remove a proton and form something like this, double bond O. Carbon number 1 will have 2 pH groups. Okay, carbon number 2 will become C double bond O. Carbon number 1 has 2 pH groups. You can put 2 anywhere in the ring and form this compound. Okay, अगर आपने 2 यहां पे रखा तो यहां पे C double bond O बना दीजिए, and this if is made as 1, then you will put 2 pH groups over here. Okay, so that's an arbitrary choice. आप कहीं भी रख सकते हैं. This structure is fairly correct. Okay, so this is a very important question. इसको अगर आप समझ लिए, please do practice it again. Let's move on to the next question. Let's look at the question. It's a vicinal diol. पहले vicinal diol हमने देख लेना है. Now, if it is a vicinal diol, हमें identify करना है कि कहाँ पे carbocation बनेगा. So, what I do is I write both the carbocations in my rough part of the notebook. So, ये आपके पास एक ये कार्बोकेटायन बन सकता है. You can form something like this. Okay, or you can form a carbocation something like this. You can form any of these 2 carbocations. Now tell me something, which is a more stable carbocation? Is the left one more stable or the right one more stable? It's very easy to identify. Positive charge on the ring is not stable. This will not be formed. This will be formed. Okay, now how would the rearrangement take place? Remember in the previous slide what I did tell you, that if there is a carbon atom adjacent to a 4-membered ring, ring expansion will occur. If there is a carbon atom bearing a positive charge adjacent to a 4-membered ring, a ring expansion will take place. So I'll write something like this. This is OH, this is a CH2 with a positive charge. If ring expansion occurs, so how would I write this? Let's label this as 1, 2, 3, 4, 5. Which bond should I be breaking so as to form a bond between 1 and 5? I should break the bond between 2 and 5. So I will draw something like this. Okay, clear? So carbon number 2 is adjacent to the carbon of the benzene ring. So this will become 2, this will become 3, this will become 4, this will be 5, this will be 1. And if 2 gets a positive charge, and finally our product will look some this would be our product. Okay, this would be our product. It's a very simple question. Try to resolve this. बहुत simple question है, बहुत आराम से solve हो जाएगा. ठीक है? Let's look at the next question. So in this question we have to identify that whether the products formed are alike or different. So in this question we have to identify that whether the products formed are alike or different. Now I had told you that Pinacol Pinacolone rearrangement is a very important reaction. इसमें important दो चीजें आ जाती हैं. एक तो अपने कार्बोकेटाइन को rearrange कराना है. Ring expansion can take place. Also ring contraction can also take place. ठीक है? So let's look at this question. Let's take the first question. I can form a carbocation at either of the 2 points. So I can form a carbocation over here, or I can form a carbocation over here. If I form a carbocation at any of these 2 carbon atoms, I can get something like this. Okay, I'll get something like this. Now what will happen? In absence of any migratory group, the ring will contract. and we would obtain something like this. यहां पे कोई फिनाइल मिथाइल हाइड्राइड तो प्रेजेंट नहीं है, so what will happen, this ring will contract because I have to somehow bring the positive charge on the carbon atom which is attached to OH group. So this contraction will take place. So this is ring contraction. Ring contraction can take place if there is a need. Need is that a more stable resonance stabilized carbocation is getting formed. So what will be the product over here? I remove a H and I form a carbonyl compound. ठीक है? Let's look at what would happen over here. इसको बनाना बहुत easy है. आप एक जगह से OH को हटा दीजिए, you'll get a carbocation, the 5-membered ring. यहां पे एक पॉजिटिव चार्ज आपने लगाया. Now 5-membered ring, adjacent to it, the carbon has a positive charge. No matter whatever is attached to the carbon atom, if the carbon has a positive charge, it will undergo expansion. Okay, it will undergo expansion, and if expansion takes place, what will I obtain? So let's number the 1, 2, 3, 4, 5, 6. Okay. Expansion takes place, bond between 1 and 6 will be formed, bond between 2 and 6 will be broken, and the carbon number 2 will acquire a positive charge. So what will be generated? This is carbon number 1, carbon number 2 will be this OH, यहाँ पे positive charge आ जाएगा. Finally you will get so the nature of product obtained in both the cases are same. However, in the first case you are seeing ring contraction taking place, in the second case you are seeing ring expansion taking place. Okay, let's move on to the next question. So we have now learned about Pinacol Pinacolone Rearrangement. We will now try to learn about a slightly modified version of it, which is known as semi-Pinacol Rearrangement. Now what is semi-Pinacol Rearrangement? In a semi-Pinacol Rearrangement, rather than having a diol, we have a group present at a vicinal position. Let's look at the write-up for that. When a substrate has a group X vicinal with respect to OH, when a substrate has group X vicinal with respect to OH, the reaction proceeds by removal of leaving group, forming a carbocation as electron deficient center. इसका मतलब क्या है? You can see this group. This group is present at this carbon atom. This carbon atom is adjacent to this carbon atom where OH is present. So this X becomes vicinal to OH. Now if this X is removed and I get a positive charge over here, then this group will migrate and I'll get a C double bond O unit. Now what can this group be in a organic compound so that semi-Pinacol rearrangement can take place? This group X can be halogen. Okay, and in that case the reagent that you would use is AgNO3. Sorry, the group can be NH2 and the reagent can be HNO2. See, this is a very efficient way of directing a Pinacol Pinacolone rearrangement. पहले केस में क्या था कि जहां पे स्टेबल कार्बोकैटायन बनेगा वहीं पे पॉजिटिव चार्ज डेवलप करेगा and to that rearrangement will take place. But in this case wherever the group is present, wherever halogen is present or NH2 is present, positive charge will be formed only over there. Okay, positive charge will be formed only over there. So halogen and AgNO3 if is present, then if halogen is X and the reagent is AgNO3, then wherever halogen is present, I'll form a positive charge over there. If NH2 is present and the reagent is HNO2, wherever NH2 is present, I'll put a positive charge over there. Let's look at the application of this. So in this compound, what we have is a NH2 group present adjacent with respect to OH group. Okay. Now, ideally अगर हम इसका Pinacol Pinacolone rearrangement करते, जो कि typical Pinacol Pinacolone rearrangement है, and if I would had used H plus ion, the H plus ion would had got attached to OH group at the carbon atom where two pH groups are present, so that a more stable carbocation is formed. But लेकिन यहाँ पे होगा नहीं, क्योंकि जैसे ही हमने HNO2 ले लिया, then OH will not convert into OH2 and get rid as a water molecule to form a carbocation. Rather, NH2 will get removed as NH2 will get removed as N2 plus. So होता क्या है? You will get something like this: PH, OH, C, N2 plus. Let's not get into that part, that how is an N2 plus formed. N2 plus gets formed over here. Now you have to remove this. You will get PHC, PH, OH. I'll get this positive charge over here. Now one of the phenyl groups will migrate. You'll get this ion, you'll get this carbocation, which will now lose the H plus ion to form PH, C double bond O, C, Me, PH. Okay, very simple. अगर HNO2 दिया है तो NH2 remove हो जाएगा, not OH. In this case, we have Br present with respect present vicinal with respect to OH. We have Br present vicinal with respect to OH. So when we take AgNO3, then Br would get removed because AgNO3 will react with any alkyl halide to remove the halogen and form a carbocation. So what we would do is PH, OH. So I'll remove this as AgBr, Me positive charge, pH. Okay, and then remove H plus ion. You'll get this. So with this we conclude today's session on Pinacol Pinacolone rearrangement. I hope you have understood what are the intricacies of this particular rearrangement, and please do solve the same questions again. The next session would be on Friedel-Crafts reaction, and Friedel-Crafts reaction is very, very vital for anybody who wants to master a certain aspect of electrophilic aromatic substitution. Please do attend that session, because in that session we will be learning Friedel-Crafts alkylation as well as Friedel-Crafts acylation completely. Okay, so with that I take leave, and I hope to see you guys in the next session. Bye bye.